So today now we are gathering here to discuss about our final year projects. So this project is completed by our final year students. The project title is Solar Tracking Robotic Arm for Concentrated Thermal Applications. So before entering into this robotic arm, first we know what is solar thermal technology. So the solar thermal technology is nothing but we can directly convert the sunlight into the useful heat. Okay, this is called solar thermal technology. It is classified into basically three types. One is low concentration, medium concentration and high concentration. So the flat collector and the evacuated tube collector comes under the low concentrated type collectors, and parabolic trough collectors comes under the medium concentrated type collectors, and parabolic disc comes under the high concentrating type of collectors. Okay, so now our batchmates completed this project by using the robotic arm tracking the movement of the parabolic trough is integrated with the solar photovoltaic cells. So let us discuss one by one what are the methodology we can carry out for this project, what are the advantages, what are the applications, and how the generative AI is integrated with these projects. Let us continue one by one.
Hi everyone, my name is Abhinav from SNS College of Technology, final year mechanical engineering student. I am here to talk about solar tracking robotic arm for concentrated thermal applications. And this system automatically tracks the sun movements and it helps to improve the efficiency of the solar absorption energy. And if we compare to the traditional fixed solar panel, we use a robotic arm for tracking the sun movement, and it helps to improve the efficiency of the solar energy absorption. And further we'll be talk about this project. I invite Kanish.
Hello everyone, I will explain the parts and the working principle of our project. This is our base frame with 4 sensors. Basically, we use the NDA sensors for four sets because of the sun directions and movements, and we have used the 2 batteries because of one for motors, 2 motors. One it is upper for 180 degree, for down 360 degree, another for a microcontroller processes, and we use a power bank extra. It helps the ESP for controlling for Wi-Fi module, and we had make the project two process, which is manual model and this automations. With this, we have tracked the solar light, sunlight using the automations are same like manual. We can now explain the work of the project.
So basically, you have completed this project by using 4 LDR sensors in each direction. The LDR sensor is nothing but it is the light detection sensor. Whenever the sunlight is concentrated on the particular portion, it gets energized and then it gives the feedback to the microprocessor. At that time, the parabolic trough collector or photovoltaic cells is tilting, or it is called tracking. So we are here implemented the robotic arm tracking. By using the robotic arm structure, we can tracking the sunlight. Okay, explain the working procedure.
Now the main object is we use the parabolic dispenser for the reflection of the sunlight through the solar panels. Now I work the model. If the sun passes in these directions, the panel will rotate on this side, and if the sunlight passes here, it will rotate to left. Let's see. Actually, this method is fully 360 rotation, and this layer is only 180 degree. For the sunlight captured from north to east, like that. Next, the working principles is done by me, and after the problem statement given by the Harish Babu.
Myself, I am Harish Babu, SNS College of Technology, finally mechanical engineering. Now I am going to tell the problem statement of this project, and the main problem statement is energy conservation of fully in a 3-to-1 axis principle, 3-to-1 principle, which is to be done in the design and it will be done in a parabolic disc. With that, I have done a design intellectuals with 180 degree and 360 degree parabolic disc. With that, I have controlled to the assembled in the SolidWorks. With that, I have explored the one main process with the adjustment of the technique, which is different from the other than the solar tracking robotic arm, which is implemented in this, and this useful things are which is used for cost efficient for this robotic arms. And then next forward to the
Hi all, my name is Varun. So the main advantage of the robotic arm is that we get the maximum efficiency compared to the traditional solar system. So we have built it in such a way that everyone can afford it according to it. In future, for more industrial purpose, it can be made in a large scale and can be access to it. In agriculture areas, commercial areas, industries, etc. can use this project for getting the maximum efficiency by the sun and get the maximum energy.
So let us conclude anyone about the summary of this project.
Hi, myself N.R. finally mechanical student business college technology. This is based on the solar working principle. The solar panel collects the solar energy and transfers to the battery, and to the battery it rotates or tilts according to the LDR sensor from the sunlight. And it uses the DC motor, two DC motors, a right angle DC motor with the spark gear. And in that right angle DC motor, it rotates about 300 RPM. Both the DC motors rotates at 300 RPM. By using of Arduino, by the source code as mentioned, and using of source code, it according to the LDR sensor, it rotates and collects the sunlight and powers the battery.